Hello again, HC Science students on track A. We're looking here today at Thursday, January 7th. Your main goal today is to finish Tectonic Investigation 4. We got that started yesterday in class. So kind of as you buzz through here, hopefully in class you kind of got through step 2. Again, a reminder that enhanced bathymetry topography that we're looking at here. Topography is sort of the bumpiness of the surface of the land. The redder it is, the higher it is, the greener it is, the lower it is. And bathymetry is sort of the same idea, but for the seafloor. The lighter the color, the shallower it is, the darker the color, the deeper it is. So they can walk you through some of those things as you go. A reminder, as you work through, they are going to do some filtering of these earthquakes. These query means ask a question to filter some of those things down so you get just these extensional earthquakes. Is what they want you to be looking at. Again, extensional means like to pull apart. So if you extend something, it gets longer. Same thing if you're diverging. If your plates are diverging, they're extending. So those things, ideas should be the same in there as you work through. As you continue, they get into kind of some of the depths of some of these earthquakes as you go. And kind of looking at that motion. Look at kind of how deep are these earthquakes happening as you go. And there's something about how deep they can be and the thickness of the lithosphere in there. So pay attention to that. Again, that surface heat flow, we're coming back to that idea of the convection currents are driving. That's kind of that up bubble on the convection current that we see as we work through. And kind of following through the directions, make sure you're paying attention to how deep the earthquakes are. They have you. Step 4 is an interesting one. I like step 4 because they have you calculating the divergent boundary spreading rates. So they look at the half spreading rate is what they're going to have you calculate. So when you look at the age of the ocean floor, pay attention to the colors. Remember the color on the outside here is not the darkest one. The darkest section is going to be all the way over in the Mediterranean. So pay attention to how old this is. So when you get to, I think it's this question here, 7 and 8, basically what they want is you have to measure a distance. Use the measure tool. We've done that before. You remember how to do that. Measure the distance, and they ask you for the age. Well, how old is it? Whatever you get take this number divided by this number, whatever you have in those two, and put that number here. So you'll end up with something in kilometers, because your distance should be in kilometers, per millions of years. So just leave this number in per millions of years. Don't try and do any crazy conversions, but kilometers per millions of years. So take the top number divided by this number and just leave it in kilometers per millions of years as you're going through. Okay. If you have questions on how to do that calculation, please make sure you ask. If you can at least get the numbers in there that you would need, and we can maybe talk about it when we get to class on Monday. But just divide them is all you got to do. Pretty straightforward. And then you talk about how much faster they're going, which one's going faster, which one's going slower, and how much faster. Okay. And then we get to this question. It's a little confusing. So number 10, actually kind of the picture for number 10 bumps onto the next page. So here's the picture for number 10, and just make sure you're getting that in there correctly and answering the question. Okay, I think they have you write some ages and some elevations, so you have to do some editing of that image to get in there, or you can just write underneath. That's fine too. Okay. As we continue. That's 7 and 8. Yeah, so we look at this transform faults along the divergent boundary. So one of the things we'll look more detail out in investigation 5, which is why it's good to do these two together, is kind of throughout the layer here. Oops. Layer profile. If I turn on the plate boundaries, one of the things we'll find as we look up and down, like the Mid-Atlantic Ridge here, is that it'll be a divergent boundary. The green is the divergent boundary. And periodically throughout there, we'll get these little gray transform boundaries kind of scattered throughout. There's a whole bunch of these things in there, and we'll look in more detail at these for transform boundaries. But there's lots of them kind of scattered throughout. There's a big one up here. It kind of pushes it to the side. So pay attention to those, and that's kind of what the step 5 is all about, is looking at kind of how that elevation profile changes And that's what they've drawn in here. So again, look at the age, look at how that changes in there. Just follow the directions for those. But that's what they're looking at. Answer those questions. Again, a reminder, I did put a spot for there's some screenshots that you need from step 6. So as you work through step 6 is going to be all about discovering how the passive margin forms. So kind of looking at that edge of the difference between oceanic crust and continental crust. So you can see on the label here, and then you'll see this as you dig into it. Oceanic crust, that's mainly that basalt crust, whereas continental crust is much more variety, and there's kind of a transition that happens in between those. And so that's that passive margin that they're looking at. And they have you do some drawings and kind of try and find out where this stuff is. Make sure you take screenshots and put those right in the right box. So there's 2 different ones that you want. Make sure you get the right one in the right spot so we know what we're looking at. Okay, I'm kind of playing this back in time is what they have you do. They have you sort of reverse time of what happened. How many, let's see, I think we get to those pictures. It's, I think in N, they want you to go to 90 million years ago. And then in S, I think they have you go all the way back 180 million years. I forget. Follow the directions, but make sure you get those screenshots in there. Okay. As always, as you work through, folks, make sure you ask if you have questions. Really, today, finish up to Tectonic Investigation 4. Tomorrow, we'll be looking at Tectonic Investigation 5. You will have a chance on Monday to ask some questions if you need to. And on Tuesday, these are going to be due. In class, we'll go through, we'll check them, number 1, number 2. I'll pull popsicle sticks. Make sure you've got the right understanding in there so you can move forward on those. Okay. Other reminders for you as we wrap up today. Make sure you're going and filling in your moon log. A good time to look for the moon currently is in the morning. Kind of anytime after midnight, 1 o'clock in the morning, all the way up through noon or so. So morning is going to be your best bet for a time to look for the moon and get those observations recorded. As always, if you have questions about anything, please make sure you ask. Have a great day.